Hey everybody, Lars here. Welcome, people of CS111. I promised everybody that I would jump on real quick and show you a little bit about Project Euler. Project Euler, if you remember, or if you don't because you're not in my lecture, is a site that has roughly 700 number theory problems, and they lend themselves to being solved with computer programming. So what I always tell people is that learning a computer language is like playing an instrument, be it guitar or be it piano. What do? You sat down and you learned your scales. If you play guitar, you got Mel Bay books and you had to, learn the neck and yada yada. But eventually what you did in order to start having fun and to start using the guitar or the piano for what you wanted to do, you got songbooks, right? And you learned how to play different songs, country songs from the 50s, simple rock and roll songs. And you started working on that, and then you could do what you were meant to do with your musical knowledge. That's why you learn the instrument in the first place, right? Well, we learn computer programming so that we can solve problems. So what better place than to come to Project Euler, where there are over 700 problems. Think of this as your songbook, as you're practicing and you're learning to get better with your computer programming. Now, what I've done here, and should I sign in now? I might as well, is I've come to Project Euler, projecteuler.net. I'm going to say sign in. I don't want to sign in as me. I'm going to sign in as CS111, F for fall, 2020. The password is Java class, all lowercase, all together, one word. And then let me make the CAPTCHA happy, because I'm not a bot. And then I'm going to sign in. Sign in successful. Why, thank you. And then, as you can see up here, we're logged in as CS111. If you'd like, as you solve Euler problems, you can come here. And as a class, as a group that took 111 together in the fall, we can all solve as many problems as we want. The problem we're going to look at today, and here, if you go to progress now, because you're logged in, you can see 727 different problems. And if you want to go look at one, you just click on it, and it'll take you to the problem. Now, I'm going to come right out and say it. What we're doing tonight, you're not supposed to do, okay? You're supposed to leave these things unsolved so that other people can come and solve all of the problems, okay? Newsflash. Everybody knows about Stack Overflow. Everybody knows about GitHub repos. Everybody knows about Chegg, all right? These are no secrets. If you want to go try and get the answers to maybe the first 100, 120 Euler problems, they're out there. C, C++, Python, Java, the solutions are out there. Try them yourself first. If one really stumps you and you've been going at it for a day or two, maybe then you go grab an answer or something like that, okay? We're going to take a look at problem 6. It's fairly simple. When I show you the stats later, you're going to see that everybody has solved it. So I sleep at night knowing that I've solved this online, and this is the one that we're looking at, okay? Basically, it's this, and I'll tell you the reasons I like it as we go. The sum of the squares of the first 10 natural numbers is, and you see the equation there, 385, okay? The square of the sum them up first, then square that, is 3025. You take the difference, and you get 2640, okay? So that's what we would call a worked example. We see the problem being solved for the first 10 natural numbers. Project Euler then turns around and says, find the difference between the sum of squares of the first 100 natural numbers and the square of that sum, okay? So we're going to do something that's actually pretty common in computer programming, is that we're going to solve the problem for the case that we know, and then we're going to change some of our parameters to solve the problem for what we don't know. So basically what we want to do is write some code to solve this problem with 10 first, because we know the answer, okay? So what I'm going to do is I'm going to highlight this, and we're going to have to play some games because they put some graphics in there. And we'll change it when we get in there. And let's go write some Java code to solve this problem. I'm going to say File. I'm going to say Open Folder. I'm going to go to my CS111. I'm going to say Euler code, and I'm going to create a new folder. I'm going to call it Euler 6. Okay, we're going to select that folder. then I'm going to hit Control N, or I'm going to come up here and I'm going to say New File. Remember, that's how we get a program. And I'm going to say public class, because we're in Java and everything runs in a class, and I'll just call it Euler 6. And I put my braces down there, and then everybody's favorite beginning, public static void main string args. Remember, args, it's just a variable name. You can call it anything you want. All right, so now I have a shell and I can write a program. I'm going to give myself a comment. Actually, I'm going to give myself a multi-line comment, and I am going to paste the problem in. Only I don't have the numbers, so we'll have to go get them. We'll do that, and then to make it readable, we'll bounce that down there, bounce that down there. All right, and then we will end the comment there. The sum of the squares of the first 10 natural numbers, memory serves me, is 385. The answer to this is 3025. And the sum of the squares is 2640. Look at that, 2640. Okay, so now in the comments of the code we're writing, we're actually going to have the actual problem, which is pretty helpful. I'm going to cut to the chase, and I'm going to call this Euler 6.java. And this way, VS Code is going to start to color my code, catch some simple errors that way. I can see that all those comments there are green, and that makes me happy because that's what I want. Okay? So now I have to set about solving this problem. I say problem, singular, but what is this? This is really 3 different problems, right? I've got to find the sum of the squares. Then I've got to find the square of the sum. Then I have to find their difference. So my first blush is let's tackle this one thing at a time. The first thing we're going to do is we're going to find the sum of the squares. Okay? And how are we going to do that? Again, the whole reason we're going to Euler is, like I said, think about the first 4 weeks. Don't worry about week 5 yet. Don't worry about arrays. Think about all the tools that we have in the first 4 weeks. The pseudocode. We know how to solve problems, right? We know how to read input. We know how to compute. We know how to put things in expressions. We know how to display our output, okay? And after week 4, what do we have? We have some control structures. We have if-then. We have a while loop. We have a for loop. So all of a sudden, I want to do something with the natural numbers from 1 to 10. That puts me in the mind of a for loop. So let's say for. I'm going to grab a variable I. And I'm not going to make it equal to 0. I'm going to make it equal to 1 because I want to go from 1 to 10. Okay? Then I'm going to say I is what? I want to keep going as long as I is less than or equal to 10. And then I'm going to, not capital, I'm going to increase it by 1. Now, I'm only doing one thing here. So I'm not going to create braces. I'm just going to keep going and give it my one command. Now, what do I want to do? I want to find the sum of the squares. So as I go through this loop, I want to take the square of I and add it to an accumulator, right? If I'm going to use an accumulator, I need a variable. So I usually do that at the top of my programs. So I'm going to say int, and I'm going to say sum of the squares. I'm going to make it equal to 0. Okay? And then here, for my command, I'm going to say sum of squares plus equals. Remember, it's an accumulator. I want to keep adding the old value in sum of squares plus something to the new one. But what do I want to add it to? I want to add it to the square of I. Okay? Now, Java, different languages have different ways of doing things. So you could do it 2 ways. You can call math.power and raise it to the second power, or at the end of the day, it's a square. In parens, I times I butters this particular biscuit. Right? Give that to the end. Good. Now, what I do I check things incrementally as I go. So I'm going to say print line. And I'm going to print sum of square. And I'm going to make sure that I'm in good shape as I'm going along. So I'm going to save this. I'm going to grab a terminal. I'm going to say Java C, Euler6.java. Uh-oh. I don't like it when I don't have errors. I don't type that well. Something else may be afoot. And then I'm going to say Java Euler 6. And it's going to say 385. Well, that means it's correct because look, 385. So I have the sum of squares for 10. So I'm in pretty good shape there. Okay? Now, in case I want to debug later, when I have a little print line in the middle there, I usually don't delete it. I'm just going to comment it out. All right? It's not hurting anybody. So we just leave it sitting there. I think my OCD is going to make me put it up there, though. All right? So now we've solved our first problem. Now we can move on to the second part. Second part is what? I want to find the square or the sum of the first 10 natural numbers. Well, I don't want to repeat all my work. So I'm going to copy that. Come down here, and then I'm going to doctor it up for the new thing. So what do I want to do here? I want to find the square of the, and I'll even use that as the square of the sum. So now, same loop, only now I don't want to use that same variable. See how VS Code is lighting up that same variable for me? Let's call this one square of sum. So SQOS, okay? Only I don't want SQOS to be the square of I. I want it to just be I. And I'll leave it in the parens, why not? But I just created a new variable, yeah? So let's declare that guy. Done. Okay, could have done it on the same line. It all depends. At the end of the day, you're going to want your code to be readable as well. So sometimes when you do things on different lines, it makes it more readable. I can look there and very quickly know I'm dealing with two integer variables. I digress. So now, system out print line. I'll go square of sum here. And while I'm at it, I'm going to uncomment my comment right there. I'm going to save. I'm going to come down here. I'm going to hit the up arrow twice. I'm going to hit the up arrow twice. Something went haywire because I just got 55. What do I want to do? Oh, I didn't square it. I have things summed up because 1 to 10 is 55, but I didn't square the result, and I want the square of that sum. Well, that's pretty easy. Like I said, we're dealing with squares, so just multiply it by itself. Got that line in there, so we puzzled that out before we went to the third step. Now I'm going to come down here, up arrow twice, recompile. Of course, I forgot the semicolon. Said the recovering Python programmer. Again, I did it again. Where? Did I not save? I must have not saved. That was it. All right, 385, 3025. Okay, so I'm getting the right answers for the right numbers here, but I'm not done yet. Because what do I need to do? Find the difference. I'm just going to print it out in the line. System.out, print line. String literal. The diff is plus space in parens, because I'm going to do myself a little arithmetic. What do I want to do here? I want to do the square of the sum, right? Square of the sum minus sum of the square. That looks to be in the right place. Semicolon to end the line. Save. Up twice. Up twice. Look at that. 385, 3025, 2640. I come up here and I see that the answer is indeed 2640. So I have just written code that takes the natural numbers from 1 to 10, finds the square of the sum, finds the sum of the squares, and finds that difference that it's looking for. But I'm not done. Okay? Because the Euler problem ask for the difference between the sum of squares of the first 100 numbers and the square of that sum. But, as you can probably guess, because we've done this with computer programming, it's a matter of me just having that go up to 100. So now I rerun. First I recompile. And now I get this number. 25164150. We'll get back to that in a second, because we're going to take that number and we're going to go over to the Project Euler site and we're going to see if we're right. But first, there's a couple of things that we have to do up here. My OCD is not going to let us make hard code numbers in our for loops. So I'm going to change that to n. I'm going to say n is n. I'm going to say int n. And I'm going to say integer dot parse int. I called it Euler, didn't I? Had to be a pain in the rear. So I'll call it Euler here. Euler 0. So I am going to give the number at the command line, and then I will use that number in my loops, and I will get the proper answer that way. Save. Recompile. Run. It doesn't run. Why? Because I didn't give it a number. Let's do our old example. Oh, and I see my numbers are good there, so I know I'm in good shape there. Now I'm going to add a 0 and give it 100. So now my code runs, and my code is run for the first 100 natural numbers. Square sum of the squares, then square the sum, then I find the difference. Okay? There's another couple of things we could look at up here. I look at that loop and I look at that loop. They're the same thing, right? So maybe we could consolidate them and do both commands under just one loop. That depends on how you like to do your programming. I happen to like the way those different tasks are compartmentalized out. We'll do it when we come back so you can see it. All right, so what I'm going to do, because God knows I can't remember anything anymore, is I'm going to hit Control-C after highlighting that, and hopefully we get it. And then I'm going to go back to Project Euler, and you can see if you're logged in and we're logged in, it has a place for the answer. So what I'm going to do is I'm going to paste that answer in there, and then I'm going to click Check. Okay? It looks good to me. I think it's the answer. Because I've done this video before for a bunch of different things. And this is one of the best things about Project Euler, because when you get a Project Euler problem correct and you give it the proper answer, you get the big green check mark. Let's see how fast it takes. Waiting for ProjectEuler.net. He said, while he slurped his coffee. And there it is. Look, I'm an old man who solved this problem a bazillion times, and I still get a buzz seeing that green check mark. The green check mark at Project Euler. Now, we got that whole sum square thing licked. We're never going to have to do it again. I go to Progress. Look at that. It's already marked off. There's a lot of work to do there. There's a big desert full of problems. But this one's done. So anytime we want, we can check it now, and it'll tell us the answer. And it'll tell us when we solved it. Okay? Also has a lot of neat things, too, about statistics. You can go see the problems, how many people have solved how many. I think if you solve the first 50, you're a 5%er. Yeah, right there, 50-51. 5% of the people have solved 50 problems or more. And you can do, where are they? Progress, awards. Okay? So you can do baby steps, which is the first 3 problems. The journey begins. There's one for pi, right? Where if you do the numbers here, it is easy as pi. So you do 3, then 14, then 15, then 92, 65, 35. Okay? If you do those problems, you can get the easy as pi award. A whole bunch of different things. There are different levels for solving 25, 50, 75, 100. I'll tell you right now, if you solve more than 100, you're already up there. You're really statistics problems. Jesus, it's not even there. 100. You'll be in the top 1.2% of people who have worked on Project Euler. Like I've said, Some of the solutions are out there, but don't be tempted. Go work these problems. Use your new programming skills, the ability to create variables. You can do expressions. You can do if-then now. You can make decisions on branching. You can do loops, while loops, for loops. You can do all these things. All of these things are part of your problem-solving toolbox now. So you can take them and you can do solutions, right? If you're going to use the musical instrument analogy, you can go and learn a whole bunch of different songs. And if you go to About, you can learn all about Euler the mathematician and what the whole site is about. Or you can go to Archives and you can learn about all the different kinds of problems. And you can see the one that we did. There's discussion groups about it. There's different solutions. Once you've solved it, you can go and look at all those different things. And you can, get into all the different problems and solving all the different things, all right? We did sum square difference, but don't tell anybody else. Multiples of 3 and 5 look familiar? FizzBuzz? So Fibonacci numbers, largest prime factor. There's a whole bunch of different problems that you can solve, okay? Now, I told you about Project Euler. It's a cool place to go. You don't have to use this account. You can set up your own account. It's free, right? And so I'm assuming most people are going to do that. And then you could start solving the problems and start building up a library of problem solutions. Keep the code on your hard drive. All that said, it's not an excuse for not keeping up with your coursework and not doing your stuff, all right? Like I say to my people in my lecture, you read the book first, then you read the slides, and you look at the learning objectives, all right? You should understand all the learning objectives. If you don't, you go back to the slides, you go back to the book. You pass over those resources a couple of times. You go to lecture. Maybe you rewatch it. It's a video. It's posted, right? You put it on at night, okay? You fall asleep to it. I shouldn't say that because you should be listening. But, okay, so engage with all the resources slowly but surely. This kind of stuff, week 5, arrays, some of the stuff we're going to do in the future, you're going to add a lot more tools, to the tools you have to solve problems right now. You can take them and use them on the Euler problems. All right? All right. So where did I leave that off? Yeah, if I wanted to, I could come here and I could consolidate that loop and do both in the same loop. But I'm not going to do it. I'm going to leave it like that because it's nice and compartmentalized. And after we learn a little bit about functions slash methods, maybe we'll come back and we'll solve this in a different way. Because things that lend themselves to being compartmentalized and broken into different problems, well, when we start modularizing our code and putting our things, then each of these solutions could be a different function or method in itself. But I'm getting ahead of things. All right? Little extra stuff to practice with. You be good. Keep up with the resources. And I'll see you down the road. All right? Take care. Bye.